Finally, I hear some people saying we have now got to the stage where we will see the actual training of these large language models. What I'll assure you of is what we learned, all of it was leading up to this training of the large language model when we got to creating the data loaders for us to load the data. When we talked about loss metrics, when we talked about the model architecture and all of that, we were leading up to now seeing how the model is trained. So let us get into it. Well, it's going to be trained in let's say eight steps, and the 8 steps will be done in a loop. We'll be looping through those 8 steps. And what are they? So the step number one is there's going to be iterating, right? We're going to iterate over training epochs. So an epoch is pretty much, if you've never seen that word before, we've never done deep learning trainings before. So one epoch is one complete pass over the training set. Even if you have divided your training set into batches, you do your batches, iterate through the batches. Once you're done with the whole training set and the whole batches, that is one complete epoch. So you choose how many batches you want, and you choose how many epochs you want to train for. So as it is going through the batches, it is updating its weights, calculating per batch loss. And then after all the batches are done, it then gets the training set loss for that epoch. It does some updates as well as it goes like that. And then you have the epoch. And then you move on to epoch number two. It goes through the batches again and all of that. So we're iterating over over training epochs. But what happens in each epoch? So in each epoch, we are going to iterate over batches. Batches in training set, right? In training epoch. So that's what happens in each. So in each, if we have 10 batches, we're going to iterate in 10 for, let's say, 20 epochs, right? After when we've iterated here, this number of batches, they are determined by the size of your training set. So you can say things like, for you to get number of batches is equal to size of training set divided by the size of each batch. Those are your number of batches. That's what you'll be doing here. So we're going to be iterating over the batches. And when we're iterating over the batches, what we are going to do is we're going to reset the loss gradient, reset the loss gradients from previous batch. So that's what we are going to do. So from previous batch, we reset the loss gradient. After we reset the loss gradient, we are going to calculate current loss in that current batch, and then we will do backward pass of that current loss to calculate what are called loss gradients. And then after we do that, we use that information to update model weights using the loss gradients. Some of these you really do not need to know in detail what happens, because if you have never seen how backward propagation works, but that's essentially what we're doing. We calculate the loss in a forward pass, right? This is the forward pass. We calculate the loss. We now know, oh, okay, it's 10. And then we backward pass that loss information. And what would just be happening is the model weights are now updated so that in the next batch, hopefully our loss is less and gets less and less. So it means our model is training as we are looping through. So now we've done this loop, we update the model weights, we move on to the next batch, but let's see. I think the best will be putting 7 here so that we print training and validation losses. The reason why I'm trying to build like a step, trying to build like as if we're writing code, losses, and then 8, we generate simple text for visual inspection. So that's what we are going to do here. So after one epoch, if after an epoch is done, we then generate simple text and we go back up and we go back up. Then we go move on to the next epoch. So this is this part here, part here, this part is what we are going to do. These are the usual steps used for training deep neural networks in PyTorch. You reset the loss gradients from the previous batch. Then you calculate your current loss in that particular batch. When you've calculated your loss, you then backward propagate the loss gradients. Backward propagate your loss gradients, and when you've done that, you then update your weights. And you move on to another batch, move on to another batch, move on to another batch. That's why I think in the beginning of the course, we did say batching. When we introduced batching, we said batching is a way to efficiently train models. Because imagine you have all these 2 trillion tokens to just do them at once in one go. It doesn't make sense. It's not efficient. I don't think you can actually handle those. So batching them means you are updating the weights in stages, more in small steps, in small steps, in small steps that are more efficient. And then you use also epochs to say, okay, epoch number one, for the model not to just do one run through the whole training set. Maybe you want to do it a couple of times. So that's where the epochs will come in. So let's see this when we are doing it in code. Again, the code might look complicated, but just go line by line with this intuition that we have now. So we have this train model. Simple is just a simple way of training. The way we are calling it simple is because there are more advanced techniques that we are not going to take into account in this course. Some of them are learning rate warm up because you're going to use a learning rate in your optimizer, cosine annealing, some things like gradient clipping and all of that. We're not using them in this course. So we're just going to keep it very, very simple using what we have just discussed now. So we are going to get our model, our train loader, which is our dataset loader, our validation loader, our optimizer, how we are going to optimize our weights, and then the device we are going to use, number of epochs, evaluation frequency, and all of that. So now we are going to initialize these lists to just track. They will keep track of our train losses, our validation losses, and our track tokens that have been seen. How many tokens have been seen by the model? We are going to track them there. And that's what we want to set up. Token scene, of course, we are going to start off with 0. So now we're going to loop through our epochs based on the number of epochs that we put in this function. What is this going to do? It's going to set the model into training mode. Because remember, our model in the previous part, we had set our model to, let me see. There's a part above here. I'm not going all the way back. The reason why I'm going all the way back is because, okay, maybe you look for the line that I'm talking about. But we had set our model to eval. So when we had set our model to eval, we just wanted to calculate our training and validation loss without having to say we are in training mode or anything. So here we are now taking it back into training mode. That's just it. And then we said we are looping over the epochs. And when we're looping over epochs, we're going to loop over the batches that are going to input batch, target batch in our train loader, because our train loader is going to be giving us input batches and our target batches, right? Like we saw in our previous video. And that's just it. We reset our gradients, we calculate our loss. This is going to be using that calculate loss batch that takes our model, takes the divides, gets the input batch, does everything, applies the model itself, the model that has all the attention weights, all of those things. And then at the end, it does the normalization, blah, blah. This is taking everything. And then it just calculates the loss with our logits. It calculates the loss. It has a logits, right? That function, it outputs the logits, but the logits are then done softmax with torch and all of that. But here it's just calculating the loss. It's happening in the background because we actually have the function up there. You can go back and look at it. Input batch, target batch is sent there, and then now we have our loss. Then we calculate our loss gradients. This is back propagation. And here we update our weights using those using the loss gradients we've calculated, and we just update like how many how many tokens were in that batch, how many tokens were in the batch. We had these many tokens, so we just say these are the ones that have been seen and all of that. We're just using that so that we can do some tracking here, and we'll show where it's printing. And then after this batch, after the batches have run, they've optimized each batch in that epoch. We are now done with that training epoch. Epoch, we then just generate a print sample. We generate some words to see, okay, for this epoch, it has trained through the batches. What is it writing now? They were just curious because we have two functions here that are important, right? We have the function that is we have some functions that are going to. Okay, let me show you what the functions are. So here we're going to return our train losses, validation losses, and our train track tokens for that particular epoch. No, for all epochs, for all epochs. Now that this loop is run for all epochs, we then just return the train that we're appending to, the train list we're appending to, the validation loss we're appending to, and the track token scene that we were appending to throughout all the batches for all the epochs. It's straightforward. I think it's straightforward code, but if it doesn't make sense, just take line by line. Look at these four loops and see what the four loops are doing. This for loop is just looping through the batches, and this for loop is looping through the epochs. That's it. Then we have this evaluate model. The evaluate model pretty much is the function that prints the training and validation losses after each model update. So we can just evaluate. We can evaluate how the model, whether the model is training or it's improving. So we are going to return the train loss and the validation loss. Those are going to be numbers. They're going to be numbers. And we are going to use it here. We are going to see as we are batching, going through the batching, we are hoping that from one batch to another batch to another batch, we are hoping that the model is improving. So from one batch to another, we are actually going to we are going to track this validation, and we are going to track the valid train loss and the validation loss from one batch to another using this evaluate model function. And we are applying it here. And we're printing some stuff that we'll see. And then we have this function generate print sample that we mentioned here, that after one epoch, we just get the tokenizer, devise the start context, and we just print to see. Even though this one here is the numerical loss and the train loss and all of those are numbers, it'll be good to see the numbers, but it's also good to see in words after the whole epoch. This one is tracking per batch, per batch, per batch. This one will say, okay, all the batches are done for this epoch. Let's see what the words are, and then that's it. So let's if we are going to now just, because this was just a function, we are now just going to put the actual arguments in it, and that's what we're doing here. The model that we're using is our GPT. That is the config that we set up at the beginning, and the device that we're going to use is of course our GPU, because we are on Google Colab. But if you have another GPU, you can use it, or a CPU. And then we have an optimizer. We are going to use what is called Adam W optimizer. So in training deep neural networks, you use optimizers, and optimizers. A famous optimizer is Adam optimizer. It is a popular one, but here we're going to use a version called Adam W. It is just a variant of our Adam optimizer, and it just minimizes model complexity to prevent overfitting by penalizing larger weights. There's a right up, you can just Google and see what Adam W optimizer is, but it's a variant of Adam optimizer. It's the one that is just a way of us optimizing our weights. It is a function that optimizes our weights. So that's what we are going to use there. And while we are putting our model parameters, those are the ones that are going to be optimized. And the learning rate is okay. I will not get into the details of learning rates because this is not like a deep learning course, but it's just how it's a parameter of how Adam will optimize our weights. And because Adam W needs weight decay, we're going to put a weight decay here. Adam by itself, Adam W needs that. Adam by itself doesn't need the weight decay like this. You can just leave it like that. Number of epochs 10. So it means we are going to do 10 runs through the training set. So even though a training set is batched, we are going to do batches for number of batches. And then we repeat them. We repeat 10 times. Then here, that's when we are now just applying it. So we are getting our train losses, our validation losses. We are now applying our train model simple function, this one here, because right at the end, it does return our train losses, validation losses, and our track token scene. So that's what we are applying there. We are giving it our model, our train loader, our validation loader, the loaders that we discussed in the previous video, the optimizer we are using here, which is our Adam W, the device, which is the GPU, number of epochs. Here we said we're going to do 10 epochs and all of that. And our stacked context. Our stacked context that we are going to use is every effort moves you. So we're going to say every effort moves you. Let's see what the model is going to generate. So you see here, it's going to start giving us some results. It's going to start giving us some results there. And here it then gives us, so it's giving us our train loss and our validation loss. They start off very high. It's expected that they start off very high. Because when they start off very high, then they start off very high because if when they start off very high, it's because this model has not been trained yet. It has not been trained yet. Uh, and and since it has not been trained yet, the losses are very high. And here we are now printing every effort moves you. This is just now applying our generate model, generate generate sample, generate and print sample. That's what it's doing here. It's just giving it its start context, gave it its start context. And now we want to see when we give it that start context that we now put here. Our start context was every effort moves you. Let's see for that has been optimized to some extent. What is it now generating for us? So we read it. It now just it is just repeating commas. I'm not doing very well. Makes sense. Training loss and validation loss, they're still high. They start going down those losses for a bit. And you see now our words that are being printed. Every effort moves you. It's saying and. That's what it's guessing. And we keep going. Every effort moves you and. And then yeah, it's now saying we keep optimizing it. You see the train loss is going down. And we say every effort moves you to the it's it's starting to write some stuff, but not convincing. And you keep going, keep going, keep going. Right at the end, our train loss is now 0.91, 0.901, and our validation loss is 6.328. And our statement now becomes every effort moves you, and then it puts a question mark, and then it put yes, quite insensible to the irony. She wanted him vindicated, and by me, he plays them, and then it's writing all these words. The good thing is you can see that it's starting to write some coherent text, but there is a catch here. There's a problem. We are going to plot our training loss and our validation loss here. That's what we're doing there. And when we plot them with respect to the epochs, As the epochs are going, the training loss is decreasing, but the validation loss is now, it like converged around 6. It's not decreasing anymore. And this is a sign of overfitting, a very, very good sign of overfitting. So our model in the beginning, yes, it did gain some training, but as soon as it got to validation loss 6, it then started overfitting on our training set, which means in our validation set, it then could not perform very well. So we can see that after seeing around, let's just say 8,000 tokens, right? After seeing about a couple of tokens, 8,000 tokens. Of course, we in our data we said we had 5,000 tokens, but if we are repeating them, right, in the epochs is going to be 10 epochs times the number of tokens that we have in our the verdict. It's 5,000, right? So in total we have about 50,000 tokens. So it starts overfitting when it has seen around 8,000 tokens. It starts memorizing the text itself. And when it's memorizing the text itself, of course, the training loss is going to go down because it's now performing on the memorization. It's going to do well in in memorized content. But this is not a problem for us because, yeah, of course, we're not going to get a good model that has been trained very, very well, like a GPT model, because one, we don't have the data sets that are large enough. We do not have the GPU that is strong enough, and all of that. We don't have the money. I do not have the $690,000 to. I wish I did have it to just put into this training, and we don't have the days, the weeks for it to run, and all of that. But this is the mechanism of how it is done. That's the mechanism of how this model is trained, and we keep track of the training procedure in many different ways. So now that we've trained, let's say we've trained this model and it is working. Let us now look at other other ways of generating text with our model. So now let's pretend that our model is really doing very well. It has been trained. We had all the money and all the data sets, the trillions of tokens and all of that. We have put them into our model like we have done now. It has trained well. We see that our validation loss is actually going very well. And we have a test set. We have a test set on the side that we're using, and we've done the training very well. There's no overfitting. When there's no overfitting, let's now see how we can use other ways to generate text. So in the next video, we are going to look at generation strategies. In the beginning of this chapter, we mentioned 7 stages. We are now at the 5th stage where we are now looking at temperature, top K, so that we can change the way it generates text. We don't want it to just pick the one that is the largest value and then that's it. We want to see if we can change things like temperature, how it affects it, top K, how it affects our generation strategies. Let's go into the next video. But for now, let's be happy that we have trained a large language model. Again, emphasis is if we had the data, if we had the GPUs, if we had the machines and everything, the time and all of that, this is the training mechanism. We're going to put some advanced techniques there, like learning rate warm up, our gradient clipping, and all of those more advanced techniques to actually make the training more efficient, more robust, and all of that. But these are the bare bones of actually training a large language model. I hope this had made you happy to actually see it being trained. But yeah, in the next video, let's now see uh how we can use our trained model to generate new text in different ways.